A very good afternoon to each one of you, ladies and gentlemen. It's a pleasure to share some of the innovation that Coral Telecom has worked on over the last couple of years. Before I start my presentation, a quick glance on what Coral is. We are a team of technocrats with a focus on development of communication solutions. Whatever we design and manufacture, we have total control on hardware as well as software. We have a pan-India presence, and we deal with a lot of services that we offer to defense and railways. Because we have control on our hardware and software, we can customize them for specific needs of niche markets like defense, railways. We have large deployments in mission critical applications. Just for your information, the largest aircraft carrier that India is going to have, Vikramaditya, has our telecom switch in it. Entire Konkan Railway, each voice and data call goes through our telecom switches. We do various projects with Air Force like AirCan, projects with DMD, Assam Rifles, etc. We also design some of the mill-grade products, and we're now working with Norwegian company KDA, that's Kongsberg Defence and Aerospace, for even developing some products which will comply to EMP, that is electromagnetic pulse, which means even in the event of a nuclear disaster, the communication systems or the electronics will continue to work properly. We work with BSNL and MTNL. The product. This is our flagship product. Over the years, we developed a product which it's a telecom switching product. You can also call it a PBX. Now we have various different interfaces for this. On the subscriber side, we can provide plain old telephones. We could provide VoIP or SIP phones. We could provide ADSL lines. So on one single copper wire, you could have voice and data coming together. We could have various flavors of DSL. That's ADSL, VDSL, SHDSL are supported. On the network side, we can support connectivities like E1, STM1, V5.2 for providing the interface and controls to the telecom switch. For defense specific applications, we have interfaces like CNR interface, the combat net radios, or the tactical radios that defense uses. We can provide interfaces for VSAT, MPLS, MLLN connectivities. Now this is a conventional product that we've been dealing with all these years. Over the years, you all know that telecom switching moved on to IP-based switching platforms. So we developed a soft switch application, replaced the CPU of our conventional switch with another blade server which was proprietary. The soft switch application was written on it, and we replaced the TDM switch. So the old legacy platforms that we had, they started working on a purely soft switch or IP-based environment. Rest of the old legacy cards acting as media gateways. The soft switching application which was written can also work on servers, so it can be supported. It can support distributed processing. It can support disaster management, which means you could have the main processor at one location and the disaster recovery processor could be located at yet another geographically distant location. It could provide redundant backhauls, could switch between TDM backhauls to IP backhauls depending on to provide a fault tolerance to the entire system. Having done the soft switching element, we wrote an MSC layer. Once the MSC layer was written, we integrated the platform with a third-party BSS. So today, we can provide the GSM connectivities seamlessly working on the same platform. So you have one single common control point. The call control resides in one single switch, and it will switch analog connectivities, IP connectivities, as well as the GSM connectivities. It also handles data. It handles all the conventional TDM connectivities as well as IP connectivities. Now this becomes a totally converged communication platform. It can have wide applications. Theoretically, suppose there's a ship and you need a communication platform which supports wired phones, wireless phones, data devices. So this could provide a complete platform for communication in a remote, unconnected area. It could be an excellent platform for setting up quick communication deployment models. So if there is a disaster management program, an accident has happened, a fire has happened, floods or earthquake, the communication systems have broken down, this could provide an immediate mechanism to set up a communication network there. It could also be used in enterprises, large malls as in-building solutions. We all know that 70% of the voice and data calls happen when we are actually present inside a physical building. Now, if that 70% of the voice and data traffic could be routed over the landline networks, that will relieve a lot of load on the citywide spectrum usage. So it could provide an optimal utilization of spectrum by converging all your voice and data minutes on the landline network when you're present within a building. Offshore drilling rigs, it can be a communication platform to address that need. As I said, it's a single box solution. It has its own MSC, it has its own BSC, it has its own BTS, it has the soft switch, all within one single box, has its own billing solutions and NMS. It can provide like an independent, it can work like an independent telecom network for a village or a cluster of villages, which could essentially be owned by local village people, thereby creating entrepreneurial models. So theoretically, a cluster of villages, 5, 6 of them in the near, which are close to one another, could be tied up and catered to from one single switch, and there could be a local youth operating it. Now, on the wired networks, these switches that we manufacture have been operated by local people. They do the billing application, they do the NMS application, they could even do some amount of troubleshooting. So that's the advantage. The technology absorption within the country will happen, and telecom will actually spread to the masses, where the ownership will also reside with local entrepreneurs. Disaster programs could use it. It could act as an excellent hub for army deployments. In fact, this is something that we're doing with the Indian Army as we're talking. We are retrofitting a truck which is a ruggedized army vehicle, a Tetra truck. It has a VSAT on top of it, that's here. And we would have the communication switch inside this vehicle. So this will provide wired connectivities. In a communication vehicle, in a defense application, wired connectivity is a must, because whenever the disaster, the alert level is greater than 4, which means it's a near wartime situation, the entire wireless communication has to be switched down, and the communication has to operate only on the wired networks. So we provide wired connectivities. Now these vehicles, that's something which we are already doing. We have vehicles where we have switches inside. There are spools of copper wire on these vehicles. Whenever army sets up a camp in a remote jungle, they will have these wires which will be pulled out, and they'll go up to 10 kilometers. They'll set up multiple camps around it. So now the advantage is that while you had these wired connectivities and IP-based connectivities, you could also have GSM phones for quicker deployment and to provide the convenience of mobility to the users. It now being a soft switched environment can also switch any of the SIP-based or IP-based devices like IP cameras. If this vehicle is interconnected, now Army has various different type of interconnects which are available for different field operations. If there's an E1 available, we could use it. We could use 50% of it, say 15 channels of voice and 1 MB of data. If there's an IP backhaul available, the entire soft switch can act as one seamless part of the defense communication network. Now defense has its own communication network, so it could act as a part of the defense communication network. Voice, data, video, images that are captured from these vehicles could be seen and observed or monitored from within the vehicle, or they could be monitored from a remote location, including say Sena Bhavan. So that's the advantage of this kind of a communication vehicle. If none of the connectivities is available, it will have a VSAT terminal on top of it. So it would be able to provide connectivity through VSAT. Of course, VSAT will have its own set of limitations. Similarly, E1 will have its own set of limitations. If you have a local E1 coming in, the numbering plan cannot be seamless. The numbering plan will depend on the nearest numbering which is available from the station which is catering to such a vehicle. But if it is on an IP cloud of the defense network, then it could be a seamless network. So irrespective of where this vehicle is located, it could be tracked with the same standard numbering which is assigned to that vehicle. Now that's something which is what we're doing with defense. We would also have it being a GSM, it being a GSM network, so one can have multiple BTSs which are 3 kilometers, 5 kilometers away from the vehicle, so that a vehicle can provide a much larger area of coverage for GSM connectivities. We could hook it up with multiple UHF, VHF networks, so defense uses a whole lot of these. So each of these CNR networks or UHF, VHF networks can also be hooked onto this particular vehicle. It's access agnostic. It could work on all the three, media, could support all the three type of contents, voice, video, as well as data. Now, advantages of this application. Last slide. Convenience of mobile devices on your enterprise PBX, which means these mobile PBX intercoms would have access to unified communication service, unified messaging service, voice loggers, IVR applications, which are available as a resource in the enterprise PBX. It could provide a quick deployment. It's a fixed mobile converged platform, so 70% of the voice traffic which is happening within the building, although happening from GSM devices, will end up going on the landlines. Optimal use of spectrum. It is a low intensity network, which means it's an even spread of low intensity RF coverage, thereby reducing your pollution levels on account of RF. Entrepreneurial models can be created with this. Thank you very much. I'm open to questions.
It's most interesting. It's so complex that it requires certain questions which are peculiar. First of all, do these require separate handsets when these local GSM networks are deployed, or off-the-market stuff is there? Because there are also issues related when you're talking about entrepreneurial models and stuff like that. Fundamental question is, are there regulatory and spectrum issues involved that need to be addressed? Because it's one thing to serve the army because that's got the monopoly and the special right of way and privilege. But when you try to supplant the same kind of a product in a normal enterprise or community environment, there are lots of questions, so you need to please explain that as well.
Sure, good. Excellent questions. Anyway, I was expecting them, most expected questions. One, Army has its own spectrum, so Army is not an issue. Number two, the very idea or the genesis of this particular product line was that if India has to develop its own GSM technologies, if we have to make strides in creating, in absorbing the technology and creating these designs ourselves, then we need to start somewhere. So Government of India already in their National Frequency Allocation Plan has allocated a small spectrum of 3 megahertz for setting up captive networks of this nature. Okay, under the USO plan, we also intend, or that's what it, there are various lobbies working in different directions, but one of the intents is that this particular spectrum which is allocated for setting up captive networks is also utilized under the USO plan for setting up entrepreneurial networks in the villages. It has been allocated in 900 as well as 1800. India footnotes 50 and India footnote 55 correspond to these two frequency bands respectively. Now, next question which you had, in fact, that was your first question, does it require standard phones? Yes, of course. The very idea was to work on standard 3GPP products. The moment you expect me to work on a product or a technology which is different, then the cost of handsets itself will become prohibitively expensive. And then this will work like a seamless model. If my standard GSM phone, which works in the city of Delhi, it goes inside the office and becomes an intercom. So it works on standard 3GPP protocols, standard GSM phones. If properly interworked with the telco operators, then it will seamlessly work inside. So outside the office, it is a regular phone for me. The moment I walk into my office, it becomes an intercom extension to me. I hope I've addressed you.
Yeah, it's somewhat like what in an internet terminology will be like a Wi-Fi kind of a thing, where you suddenly switch off and become private and there's no billing element, relatively speaking.
Wi-Fi, the only difference is it works on a different spectrum. Not every GSM phone will be operating on Wi-Fi. Wi-Fi does not have a handover protocol. So I'm talking of a standard 3GPP. In a Wi-Fi network, I can't set up multiple BTSs and seamlessly move from one hotspot to another hotspot. Handover protocol is missing in Wi-Fi. Yes, sir.
Are you familiar with the GSMR specs? Are you familiar?
GSMR, yes.
There are some special requirements overriding the general GSM specs. Are you able to incorporate all those requirements here?
GSMR is essentially a GSM protocol 3GPP adapted for railway specific requirements. Handles signaling and data connectivities better than your standard GSM phones. Supports push to talk connectivity, etc. Now that is again a standard 3GPP protocol. We are not working on it for the time being. But if we work closely with railways, we are trying to do some experiments right now with the railway accident relief trains. Given an opportunity, if the volumes build up, we would be able to integrate that.
I'm a bit surprised because any requirement of the railways would essentially require application of GSMR specs rather than any other. So I wonder with whom are you in touch with on the railways?
Okay, right now in Bhubaneswar, we're doing this on 2 accident relief trains. More as a pilot.
No, I suggest get in touch with Telecom Directorate here in the Railway Board or Telecom Directorate in RDSO, Lucknow.
We'll do that.
You better. But the requirements are very, very stringent.
Yes. Thank you.
Thank you.
Answer is yes and no. There is a similar product available from Ericsson, which is called QuickLink. But QuickLink is not as versatile as the product which I was talking about. QuickLink is essentially a network in a box to provide you GSM network. What we've done and where we are different, like we work specifically with railways and defense, so we've integrated various different protocols and technologies, telecom technologies which go into those networks. Because they need one communication platform where, IP, E1, PRI, they also have magneto lines even today working. Railways has a lot of magneto lines. Defense has a whole lot of magneto lines. And there is no substitute for a magneto line. They will have a 10-kilometer copper wire and, behind that 10-kilometer wire, they will have 3 sets of parallel telephones. Only magnetos can support it. So we are one of those boxes which provide a heterogeneity of these connectivities. We are access agnostic. So to some extent, QuickLink is a competition. But as I said, there are a whole lot of things which we do over and above that. Yes, sir.
Did you get an opportunity to work with the RLS RTS of the Army?
Pardon, sir?
RLS RTS of Plan Aaron of the Army. Were you able to had any opportunity to integrate your product with that?
Sir, I'm sorry, I'm not aware of this. I'm not directly, SONC, we've been very closely working in it. In fact, today the Chief of Army Staff has personally seen this product, and that is how with DGIS, we are integrating it in 2H AHQ on a Tetra vehicle.
Why I said that? Because Plan Aaron is what defines the complete telecom network of the Army. So if it is not integrating with that, then it will be a problem.
Let me check up. I'll check up with my colleagues. Thank you, sir. Anything else?